So, as we continue to explore and get introduced to the coordinate plane, we want to revisit a concept that we saw earlier in the year, and that is testing solutions to equations. Now, the only thing that's going to be different about these equations is that they now have two variables, being that these equations are going to represent lines that we can graph in a coordinate plane. They have to have an x and a y that ultimately allow us to carry values that represent ordered pairs that represent points on the line. So, whereas earlier in the year we were solving single variable equations, we might just be dealing with a single variable of, say, x, and we would have a value for that one variable. We would substitute in and see if it makes the equation true. Now we're simply going to have to substitute values in for both x and y. And that's made possible by the fact that solutions to these equations are represented by ordered pairs. And we know ordered pairs are represented by an x coordinate and a y coordinate. So the 5 in this ordered pair we know represents x. So when we're ready, we'll substitute in for x in the equation. And the 23 we know represents the y coordinate in or in the ordered pair. So we can substitute in for y. So let's get started with doing that. So if we substitute in for y with the y coordinate 23, we're going to see if that is equal to 4 times our given x value, in this case 5 as the x coordinate, plus 3. And now it's just a matter of following order operations. So let's continue to do that where necessary on the right side of the equation. So I can see that 4 times 5 is 20 plus 3. We will see if that is equal to the 23 substituted and isolated on the left-hand side. Continue. 20 plus 3 is 23 on the right, is equal to 23 on the left. So the fact that we have a balance or an equal outcome proves that the ordered pair is a solution. And what we want to be in the habit of doing is not only noting what the outcome is, a solution or not, but stating what the proof is. So this is what the final answer would look like: the response to a solution or not, and the supporting evidence mathematically. So we'll go through that process one last time with problem number 3, because it incorporates a fraction, and I just want to make sure that we have some comfort in doing the same process, but even with fractions involved. So one more time, we have our ordered pair. We know the -4 is our x, which will get substituted in for x. We know the 9 is our y coordinate, which will get substituted in for y. So let's substitute those values in. So 9 is equal to 1/2 times, for the x coordinate, -4 plus 7, and follow your order operations where necessary. So 1/2 times -4 is -2, which we'll have to add 7 to, and compare it to the 9 isolated on the left-hand side. And when I add -2 plus 7, I get a result of 5, and that is clearly not equal to 9. So in this case, it is not a solution. What I mean by that is the ordered pair, -4, 9, when substituted in for x and y respectively, does not make the equation true. We can see that proof by the fact that when we follow order of operations after substituting, we get the result of 9 does not equal 5. So this ordered pair is not a solution. And what that just means is that if we were to graph the line for this equation, this point would not fall on the line. Whereas up above, where this ordered pair 523 was a solution to the given equation, it would be a point on the given line when the line is graphed for the equation. So that's really what you're looking to interpret here, whether the ordered pair makes the equation true, meaning it's a solution and therefore falls on the graph line, or is not true and therefore is not a solution and does not fall on the graph line. So I'll leave it up to you to follow this process for the remaining two problems on the top of these notes. I am going to ask you to leave the bottom problems alone. We'll get back to those when we come back to class, and we'll continue our practice then.